This question here focuses on properties of polynomials and functions, specifically factors of them. Now the first part wants me to show something's a factor. I've got a couple of techniques for that. I'm going to talk you through them both, and then the second one is after me factorising something fully and solving it. So both of these are interlinked to each other and they rely upon each other. Now, part A, there's actually two ways I can do it. I could, for example, look at the bracket, and if I imagine underneath it, I could write x is equal to -5, because if you think about it, I want the overall function to be equal to 0 as I factorise. Same idea as when I solve a quadratic. Imagine I put x equals -5 into that. What I'd end up getting is -5 to the power of 4 plus 3 times -5 cubed, take away 7 times -5 squared, plus 9 times -5 minus 30. Now if I go through that and I calculate everything there, lo and behold, I get 0. So if I were to do that and get an answer of 0, what I'd have to say is, therefore, x plus 5 is a factor. So that's one way of showing that it's a factor. And just to be clear, this communication here at the end is vital. You can't just leave it as a -5 to the 4 plus 3 times -5 cubed, take away 7 times -5 squared plus 9 times -5, take away 30 equals 0. You've got to tell them what that means. You've got to say to them, this is a factor. Now, there is another technique, and it's the one I would actually recommend you doing, and it's synthetic division. The reason being, it actually leads into part B and makes part B a little bit quicker and easier because you've actually done the first step of part B. So let's set up our table for synthetic division, and we'll follow this technique here. So I know outside it, I've got x is equal to -5. Remember, we put the coefficients of each part of the function here. So I've got a 1, I've got a 3, -7, 9, and a -30. And I'll start with my 1 down here, and I'll just go along. And what I'll do is, as I move up here, I multiply by whatever's outside. And what I'll then do is treat this as if it's a chimney sum and add them going down the way, taking into account the signs. So if I have 1 times -5, I get -5. I then do 3 minus 5 and I get -2. And I continue this until I get to my last part. So going up with -2, I times it by -5 and I get 10. Then go down, I do -7 plus 10, gives me 3. Going back up this way again, I do a multiplication, I get -15. Going down the way, from there, I do 9 take away 15, gives me -6. Multiply going up, that gives me 30. And if I then go down to there, I actually get an answer of 0. Now it's quite nice because this answer being 0, what that implies to me is that the remainder equals 0. So because the remainder equals 0, the x plus 5 is a factor. Again, that communication there at the end is vital. There's no point in just leaving it as a synthetic division table, because you've not interpreted to them what it means. And you can't just circle it. If you just get to that point and circle 0, great, you've circled a number, but what does it mean? If you don't explain to them what it means, you lose out on that mark and you lose out on that extra point, which is silly because you obviously understand what it means because you know the technique and where you get to, but why not make sure you get that final mark? Let's not lose silly marks when we're doing these questions. When we know the ideas and the techniques and exactly what we're going to be doing, let's make sure that we get them right. Second part, part B, is I want to solve this equation here. Now, in order to solve it, remember, similarly to a quadratic, set it equal to 0, which the question's done for us, and then we factorise it. Now, the interesting thing is, because x plus 5 is a factor, that is actually one of the brackets I get when I factorise. And doing synthetic division is quite nice because what it means is these here are actually the coefficients of the elements of the second bracket once I've taken x plus 5 out as a factor. So what that means is I'll have that bracket there, x plus 5, and another bracket that's x cubed minus 2x squared plus dx minus 6, and I know overall that's going to equal 0, just as the original function wants. What I now need to do is look at this cubic and figure out what I'm going to get when I factorise that. Now at this stage I can start to try values. I can start to try values so that when I substitute them into the cubic, what I'll end up getting is an answer of 0. So for example, I could try 1. I'd end up getting 1 cubed, take away 2 times 1 squared, plus 3 times 1, take away 6. So I'd get 1 minus 2 plus 3 minus 6, and what that would end up giving me is negative 4. So it's not 0, it's not a root. Bit of a heads up to you, one thing you might want to look at is factors of this last number. So look at factors of negative 6. There's quite a few there, but as you try them, they're the ones to focus on. Don't try, for example, 5 in this case. What I'm going to tell you is that if I tried x is equal to 2, and I use synthetic division to do that, I'll end up getting a solution. So if I use synthetic division, again it's a cubic, so let's use synthetic division in order to be able to get the brackets correct. Again, I'm going to put my coefficients there, so I've got 1, negative 2, 3, and negative 6 there. So 1 at the bottom, and it's the same technique each time going along. So I get 0, 0 there, 3, I get 6, and I get a 0. So lo and behold, that there's a 0, so I know that it's going to be a factor in this case. I know that that's going to be the case. So I then know that I factorise it even more, and I get x plus 5. I know I've got x equal to 2, so I then get x minus 2, and again, using this part here of the synthetic division table, I'll end up getting my last part, which is x squared plus 3 is equal to 0. So now I have to look at the quadratic, the x squared plus 3, and I have to factorise this. Here's the issue though, x squared plus 3, if I think about it and I use the discriminant, b squared minus 4ac is equal to what? What I should get is one of my 3 scenarios. Positive, equal to 0, or negative. Now if it's negative, I can't factorise it. Remember that. I've got no real roots. So if I look here and take b, a, and c from it, what I'll end up getting is 0 squared, take away 4, times 1, times 3, which I know is going to equal negative 12, which is negative. So because of that, there's no roots of that bracket. So what that means is I cannot factorise that bracket. So I'm going to be left with the 3 brackets there. I can't factorise the x squared plus 3, so it's just not a possible thing for me to do. So if I want all these 3 brackets equal to 0, I know then that either x plus 5 is equal to 0, or x minus 2 is equal to 0. My x squared minus 3 cannot be equal to 0 in any way, shape or form. So x plus 5 is equal to 0, I know that x is equal to negative 5. X minus 2 is equal to 0, I know that x is equal to 2. Now there's my 2 solutions. Now we've got to make sure we communicate the x squared plus 3 doesn't give me a solution. So that's where this comes into play. So the b squared minus 4ac, no roots, job done. We could have written x squared plus 3 equals 0. So x squared is equal to negative 3. X is equal to the square root of negative 3. And then crossed out and wrote no solutions next to it as well. The key thing is doing it though. The key thing is doing that and showing that there's no solutions. Communicating that you understand that x squared plus 3 cannot be solved. Sorry, x squared plus 3 equals 0 cannot be solved, and it cannot give us an answer for it. So we will get nothing from that. Now this question here, typically about 6 marks this one was worth. So your first mark comes from, your first 2 marks come from part A. So whichever technique you use, whether it's synthetic division or the substitution, your first mark will come from that. The second mark comes from finishing it and communicating your answer. What does it mean? Why does the remainder equal to 0 mean it's a factor? Or what does it mean if when you substitute it, you get it equal to 0? Second question then starts to build up the last 4 marks. So we get 1 for factorising the first bracket and recognising our coefficients. We get another mark for factorising again and getting the x plus 5, x minus 2, x squared plus 3. Our third mark for this question comes from one of these two techniques of showing that you get nothing for the x squared plus c is equal to 0. Final mark comes from this. Now this question, a little bit more complex and a little bit more work and wordy and a lot more interpretation coming from it, but we have to make sure we can communicate this interpretation. Always ask yourself this question. If you say something to somebody and they can ask you why, you've probably not explained it enough for them. So what you need to do is go back, explain it a bit more, and make sure they understand. If you can remember that, and you can remember the techniques of synthetic division, factorising, and solving, you should manage this question no problem. Just take a little bit more work, but overall, easy peasy, lemon squeezy.